In this video, let's look at the circuit symbol of a transistor. We've already seen that there are two kinds of transistors. One is the NPN, where a p-type is sandwiched between two n-types, and we also have a PNP transistor, where an n-type is sandwiched between two p-types. And in a previous video, we even saw what their names are. The different regions have their different names. We call the heavily doped one as the emitter. The very lightly doped thin region is called the base, and the biggest region of the transistor, which is usually moderately doped or even very lightly doped, is called the collector. Now let's look at the circuit symbol of this. The circuit symbol of a transistor looks somewhat like this. This way, like this, and like this. Ta-da, there you have it. This is how a transistor is drawn in any circuit. So you can see there are three regions. There'll be three terminals for a transistor, and these are the three terminals. So this one is the base. That's easily identifiable. This is the base. And one of these two is the collector, and the other one would be the emitter. Now, our symbol has to be a little bit better because we should be able to identify which is the emitter and which is the collector, because you've seen they're not the same things. And we should also be able to identify whether we're dealing with an NPN transistor or a PNP transistor. So the way we do this is we put an arrow mark on the emitter head all the time. So if this is the emitter, we're going to put an arrow mark over here. If this is the emitter, we're going to put the arrow mark over there. So that's how we can identify which is the emitter. And the direction of the arrow mark is going to tell us whether it's an NPN transistor or a PNP transistor. So here's how we do it. If you look at an NPN transistor, when it's working like an amplifier, these electrons get emitted from N to P, right? And as a result, there's a current from P to N, right? Because electrons are negatively charged particles. So that results in a current. Let me use some color. Okay, let me use the green itself. So that gives us a current from P to N. And so if I were to draw for an NPN transistor, and let's say this was the emitter, what I would do is, let me just write that. This would be N, this would be P, this would be P, this would be N again. And if this is the emitter, I'm going to draw this P to N symbol over here. So I would just put an arrow mark over here. Ta-da! There you have it. So the arrow mark is telling me that this is the emitter. And if this is the emitter, this is the base, this has to be the collector. And by looking at the arrow mark, one can understand, oh, this is the p-type and this is the n-type. Therefore, it's a NPN transistor. So similarly, if we were to draw a PNP transistor, the circuit symbol would look exactly the same. I mean, pretty much the same. Okay, well, let's see. Okay, this would be the base. Let's say I want to make this the emitter, and this has to be collector. Now, if I want this to be PNP, this would be P, this would be P, and this would be N. Again, if we were to make this work as an amplifier, then notice the holes would get injected from P to N. The working is exactly the same. And as a result, we will now get a current from P to N. And so I'm going to represent that on the emitter lead from P to N. So our diagram will look like this. And so that's how we can show the circuit symbol. All right, let's take a couple of practice examples. So we have two transistor symbols. Just pause the video and see if you can identify whether it's an NPN or a PNP transistor, and whether you can identify which is the emitter, collector, and base. All right, let's do it. Let's start with this one. The moment I see an arrow mark over here, I understand this is the emitter. This is the base. Base is easy to identify, right? It is the base. And here's the collector. And then I always remember that the current is always from P to N. Can you see? The current from the emitter to base is always from P to N. P to N and P to N. So the first thing I'll do is I know that this is P and this is N. Once I do that, well, if this is P and this is N, this has to be P. And so I understand, this is a PNP transistor. All right, let's do this one. The moment I see this, there's an arrow mark over here. I'm going to call this as the emitter. This is the base. This is the collector. Again, I remember the current from the in the emitter base is always from P to N. So it's going this way. So this has to be P. This is P. And this is N. And so N, P, N. Yay! NPN transistor. And one last thing is that I was always curious as to what was the motivation behind this symbol for the transistor. And this picture might give us some answers. This is the picture of the world's first transistor ever built, or at least its replica. And this transistor looks a little bit different than what we have today. And we don't have to worry about how it works. These are obsolete devices. We don't use them today. But over here, you can see this sort of like a triangle thing over here. Well, this metallic wire was the emitter. This is just a metallic wire. This was the emitter back then. This another metallic wire you can see was the collector. And this emitter and collector, these two wires were pressing on, you can see some kind of a grayish thing over here. This was the germanium that they used. This was the semiconductor, and they call them as the base. And the semiconductor is lying on top of a copper slab or something. But anyways, you can sort of see, we don't have to worry about how this thing works, okay, don't worry. But you can sort of see where this symbol comes from, right? The emitter and collector are literally sticking to the base like what we have drawn over here. And this also tells us why the base was called the base. I mean, if you look at this modern transistors, like ones we use today, it doesn't make sense. Why would we call the sandwich layer base? But over here, it makes perfect sense. That was literally the base on which the emitter and the collector were stuck. So I think they devised the names and the symbol when this transistor were built. But once we improved the transistor, the name just got stuck, the symbol got stuck, and we thought we'll just keep them.